So objectives. We're going to first be able to understand translations of English into math operations. So in other words, what words tell me to add, to subtract, to multiply, to divide? Okay, those, I got to understand that in order to solve word problems. 2, understand how to translate, how to translate. A word problem into an equation. And then we're going to review one-step equations, how to solve. Okay? Because all word problems will come up with an equation, and the word problems you're going to deal with today all give you a one-step word problem. Sometimes there's some adding, sometimes subtracting, sometimes multiplying, sometimes dividing. So that's why you see, oh, and somebody already erased problems off the board, so we'll have to go back and fill those in. We're going to have problems from the adding, subtracting homework and problems from the multiplying homework. Okay? So let's talk about some words. Or actually, let's add one more thing. It's the word problem solving process. Okay. So definitely need to go through a process as we're going through things. So let's talk about words that mean to add. So what words might you see written in English that tell you they're telling you to add the numbers together? Now, I'm not going to include the obvious one. I'll put it at the top already. Add. Okay, so everybody knows that one, but it's very rare when we actually see that. Okay, Sophia.
More?
Okay, it actually, more is not by itself. It usually couples with another word. And it's more than. I'm going to put a star next to it. I'd like you to do so as well, and we'll talk why I put that star there. Okay? Jacob, what's another one? Sometimes.
So and
Sometimes. Not every time you see the word and does it mean you're going to be adding. Okay? What are some other words that tell you you're going to add? Kyler. Some. That's the answer to an addition problem. Okay, anything else that you guys can think of? Joe?
Plus.
Okay, yep. We don't hear that one as much because that's kind of more of an old-fashioned way of saying things, but yes. Another one I can think of is the word total. Often total is telling you to add the numbers, okay?
With?
Not necessarily. I would not put that. That's a preposition. Okay, let's talk about words that mean subtraction. Shh. So again, I'll put the obvious word there. Okay, Jonah?
Less than.
Okay. Cameron, you don't need to do that. Okay. Less than, notice I put a little star next to it. You need to do that as well. Jacob, you're supposed to be writing down notes. What are other words that when you read them, they tell you you're going to end up subtracting? Joy.
Take away.
Take away. Now, I'll be honest with you, I see that more like in my daughter's homework, and she's in first grade. Again, it's kind of like how we introduce them to those words. They start real simply. Jonah?
Minus.
Minus. Okay. Jacob?
Difference.
Difference. And that's, as we're getting more sophisticated, they tend to use the words that say the answer to a subtraction problem. So that's difference. Okay? Anything else that you guys can think of? Decrease? Yep. So again, our lists are not everything that you might possibly see. They're just giving you ideas. Now, one that I didn't see that is really important, and we're putting another star next to him, and that's subtracted from. Okay. So you can have 12 subtracted from 20. That's not, it's much more common at this level. Justin, did you have one more you wanted to put? Say again? That would kind of be like less than. They would pair up with than, so it'd be fewer than, less than. There's a lot of relatives with the thans. More than, greater than, higher than, taller than, so on and so forth. So there's a lot of different ways of saying the same idea of more than and of less than. Okay, so there's some basic words. All right, so let's talk about words that mean multiplication. Shh, we're not there yet. So the first one I will put down is the obvious one, multiply. That's not a very good multiply, though. Jonah?
Multiply by. Oh, wait. Oh, you're multiply.
Yeah, thank you, Captain Obvious. Okay, Cameron. Okay. Now, this is a good one. And double has another one that means exactly the same thing. What's the other word that means doubled? If you double a number, you're also doing, Kyler? No. What was that? Casey, I think you said it? No. Twice. This is not just to multiply. It actually means to multiply by 2.
So, triple? Quadruple?
Yeah, we've got others. Triple would be specifically to multiply by 3, and we can go on. But these are the most common. What other words mean to multiply? Sophia? Times. That's a real common one. Okay, and just another one? Sometimes of does mean. What is 15% of 20? It actually is a multiplication problem. Okay, so of can often mean that. What's the answer to a multiplication problem called? Product. That's also an indication that you're going to be multiplying. Okay? All right, that's a good amount. Let's talk about division words. Shh. And this one, we've got divide. And divide by is the same thing. But there is one that gets a star that uses the word divide, and that's divide into. Half is actually to multiply by 1/2. So that's not the same. Okay, other words that tell you to divide. There's not as many in this one as we do with the other kind.
Could you just do into, like 5 into 10?
No.
Or like 5 10? Like with it into this other word? Would that be like a fraction?
Well, a fraction means it's a division, but that's not usually what shows up in word problems. Kyler? No, that's a generic name for an answer to a problem. There's a specific one, quotient, that deals with division. Okay. Divide into, we've got a star. Quotient does not get a star. So before I go on, my question is, what's special about the guys with the stars?
They all have words in
They're
them.
most commonly used.
No.
They all have words in them.
No. So if I have this, 12 is less than 20, how would I write that phrase? That wasn't an equation because I didn't say anything about an equation.
Like a little.
Okay, shh. Raise your hand. If I say 12 is less than 20, how would you write that expression on your paper if I asked you to translate that? Connor? Okay, so it's interesting that the order that I read it was not the order that I wrote it. And that's what all of these starred phrases do. They're called switcher phrases. and they switch the order of the numbers over the operation symbol. So what's written in English is actually opposite to how we write it in math with these particular switcher phrases. Now, they tend to have the than attached to them. There is the from that goes with subtraction, and there is the into that goes with the division. Multiplication doesn't have any switcher phrases. Now, we do, if we have a number times a variable, protocol is we always put the number in front. That's why he's called a coefficient. He comes in front. So even if it translates, if you were trying to translate it literally and it talked about the coefficient after the variable, we still have to write it in the customary way of putting the coefficient in front. Okay? All right, let's see. Is there something else? Oh. The other thing that we have to work with, because we're dealing with equations, is words that mean equals. So what's probably the most common word that tells you I'm going to write equals in this particular problem?
Equals?
No, they don't tend to. No, this is all going to be in words, so they're not going to give you a symbol, and they're not going to say equals. That is, again, more elementary. Okay, Joy?
The answer?
Nope. Not the answer. Justin?
Is.
The number, the word is. Generally speaking, it's all the words that mean to be. Okay? Shh, Jacob.
Trying to think of that word.
So that is the most common way that you hear equals in a word problem is the word is. Okay? So what we're going to do is talk about what do we do when we're given a word problem, how do we go through it, and then we're going to give you, I think I have 2, 3, maybe 4, depends on how much time we have problems to look at. Okay? So, start with the word problem process. Ladies and gentlemen, I am recording this, so let's keep your comments to yourself. Shh. So, I know this seems obvious, but most of you don't do this step, and this is what causes problems, is in order to translate something, you have to read what it says. So I'm going to recommend that you read the problem twice. The first time I read it is just to get an idea what the problem is about. The second time I read it is to now start pulling out information. Now, if you think back to the homework for the last couple days, in all those equations, you've been trying to figure out what a variable equaled. And a variable just holds the place of something we don't know. We call it the unknown. When we are reading a word problem, there's always something we're trying to solve for. Sometimes it's more than one thing. So what we need to do is to give a definition to the unknown. So what I call it is define the unknown. And I write it just like I would if I was in English class and I was asked to give a definition. I would write the variable, and then I'd write equals, and then I'd give it its definition, or I'd do a slash. So for example, let's say they're asking you find the number that is 12 more than 7. So we would say, I'm trying to look for a number. So I cannot, there's no mathematical symbol to represent the words the number, so I'm going to use the variable. So then I just say x equals a number. And that is called defining the variable. I'm telling you what variable I'm going to use throughout my translation, and then I'm telling you what it represents. Okay? That way, that's the only way I can write an equation, because I can't use words in my equation. Then I'm going to translate the English. Put your hand down and take your notes, please. Into a math sentence. So a math sentence has complete, just like an English sentence, it has a beginning, it has a middle, has an end, has to have a subject, has to have a verb, has to have punctuation. For us in math, we have no words allowed. We use variables to represent what we can't translate. Everything else is either a math symbol or a number. And then it has an equal sign, and the equal sign is what makes it an equation. So translate the English into a math sentence. And the one caution I can give you is to watch out for your switcher words. Or switcher phrases, I should say. If you don't switch the order over a switcher phrase, then what's going to end up happening is you're going to write your equation wrong and get the wrong answer. And that's really important with less than, because that will definitely make a big difference. All right, after we translate, then we're going to solve the equation. Just like you've been solving, using inverse and opposite operations. Now you have to write your final answer. And here's where we have a big difference, how your answer looks compared to what it's looked like when you were just being given equations and being told to solve. Okay, so number one, no variable. And here's the reason why. In the problem, it asked for what number is 12 more than 7. It didn't ask for x. You chose x to hold the spot of the words the number, or a number. So you can't give me a variable back, because if you have x equals a number, y equals a number, p equals a number, g equals a number, then that means everybody came up with a different answer, because your variables aren't all the same. So no variables allowed in the answer. What you do need to pay attention to is if you need to add an appropriate label. And by labels, I mean things like inches, miles, feet, meters, ounces, dollar signs. Now, if they ask you to solve for a number, there is no label for it, so that won't get a label. Okay? And then last but not least, you need to check your answer. And more than just mathematically, but also for reasonableness. So an example of this, we've had a couple in the Math 8A class. They were supposed to be figuring out the number of basketball teams and the number of soccer teams that 110 kids could make, knowing that there would be 5 kids on a basketball team and 11 kids on a soccer team. And so kids came up with negative numbers. And it was all, that's not reasonable to have negative amount of teams. When you're doing an age problem, and you're trying to figure out how old a kid is compared to how old a parent is or something like that, you can't have negative numbers because you can't have negative ages. You can't have fractional numbers or decimal numbers. You can't have the kid older than the parent. You can't have the kid 3 years younger than the parent. That's just gross. Okay, so, and there's lots of times when your answer is not reasonable, but kids will put it in the answer column, and that says to me, I've checked it over, I'm confident that this answer is right. That's kind of embarrassing when you give me answers that are so far-fetched that you should have noticed that and gone back to the drawing board and started all over again. So this is the process that I use every time I do a word problem. And sometimes I have to read a problem more than twice, because sometimes they're messy. And understand, with the SBAC test, the directions are a lot, because they're trying to put a lot of words in there to see if you understand them. So you're going to have to wade through. And sometimes they throw in numbers that aren't part of the problem. You also have to be smart to say, this number's not part of this, I'm throwing it out. I don't need it. Okay? All right. Now, some teachers in your past and some teachers in your future may require you to write your answer as part of a sentence. So instead of just not giving a number as an answer, which in some of these that's the case, you actually have to give context to your answers. For me right now, I'm happy with you giving me the correct answer without the variable and with a label. Okay? So let's do some problems. Directions say solve. And you're going to have to write out the word problem, otherwise it's not going to make any sense in your notes. So 7 subtracted from a number is 12. Find the number. So typically word problems are 3 sentences long. Some of them are only 2, like this one has only 2. And what they generally break down into is giving you some sort of fact, giving you some sort of relationship between two things, and giving you a question, kind of reiterating what is it that you're looking for. Okay? This one only has 2 because it's only talking about a number, so it's kind of simple. So I read it again. 7 subtracted from a number is 12. Find the number. So what am I solving for in this problem?
X.
No, what am I solving for in this problem? It doesn't mention X at all. Giovanni.
13 minus 12.
Okay, nope. What am I being asked to solve for in this problem? Sophia.
A number.
A number. So I'm going to choose a variable to represent that number. Let's choose n. So I say n is represented, or a number represented by n. So that's basically what n equals a number means. Okay. Next, I'm going to go back and look at my problem, and I'm going to look for the keywords. First set of keywords, what math are they telling me to do? Second set of keywords, where is my word that tells me equals? Okay, so operation words. What did you say, Isabel? It's not subtract.
From. Is.
Oh, my. Okay, what word or words tell you math to do? What I heard was things separated out, and then we just started guessing. Kayla.
Subtracted from.
It's this combination. Okay, so mathematically, what does it tell you to do?
Subtract.
Okay. What else does subtracted from tell you to do? If you look back to your list, what do you notice is in front of that phrase, subtracted from? The star. And what does the star tell you?
Switcher phrase.
It's a switcher phrase. So it says, I'm not going to write the 7 in front. I'm going to write what represents a number in front. Then I'm going to write my operation, and then I'm going to write the 7 after. Okay? What is the word that tells us equals?
Is.
So right now I have everything I need to write my equation. A number, n, subtracted with the 7. So n minus 7 is the translation of 7 subtracted from a number is equals 12. Okay, when I do word problems, you get 25% of the credit goes for the definition of the variable. 25% is for the correct translation. 25% is for showing me work on how to solve it. 25% is writing the answer appropriately. So mathematically, what am I going to do to solve this problem?
Add 7 to
both
12.
Yeah.
7.
I'm going to add 7 to both sides. We can use that phrase, both sides. And I get n equals 19. Okay? Now, before I write my answer finally, I am going to check it because I don't want to make any kind of silly mistakes. So I'm going to see if 19 take away 7 does actually give me 12. And it does. So what I'm going to do is I'm going to write my final answer. My final answer gets no variable, and there's no label that attaches to it, so I just box it up. And that's it. Okay? All right. Next one we have, in a basketball game, Paula scored 18 points. Shh. We don't need to have comments. This was 4 points higher than her average. What was her average? So in a basketball game, Paula scored 18 points. This was 4 points higher than her average. What was her average? What are they asking us to solve for in this problem? What is the quote-unquote unknown here? Ryan, M?
Higher than?
Pardon me?
Higher than?
Okay, nope, you're not answering my question. We're starting with the unknown. Okay, Aaron?
The average.
The average. So we'll say X is Paula's average. Okay. So now let's go back and let's tackle what it tells us. So in a basketball game, Paula scored 18 points. I can't write an equation with that. I just get 18 points. But I'm going to use that. So I'm going to circle it up. The next sentence starts with the word this. When you have a sentence that starts with this or that, it's referring to a piece of information from the sentence before. Okay, so it refers back to a fact in the first sentence. And in this case, the 18 points. Okay? So understand that a lot of these questions start with a this or that in the equation that we need to translate. All right, so the second sentence is the one we're going to translate because it's the one that compares that 18 points to her average. So what math does it tell us we're going to be doing in this problem?
Addition.
Okay, and what gives away its addition?
Higher than?
Higher than. So higher than tells us two things. It tells us plus. What else does it tell us?
More.
It's a her to switcher phrase. So 4 points is going to come after the plus. Her average is going to come in front of the plus. What word in this particular problem tells you equals?
Multiply.
So here we go. This, meaning what happened in the sentence before, 18, was, equals, and then we've got the plus for addition, 4 points higher than her average. We're going to switch the place of 4 goes in the back, and her average, which we used as X, is in the front. And now we're ready to translate, or to solve. So what am I going to do to get X alone?
Subtract from both sides.
What am I going to subtract from both sides?
4.
Okay, so I'm going to subtract 4 from both sides,
14.
and I get 14 equals X. Now, if this was a regular equation, I would have to do one more thing, and I have to rewrite it as X equals 14. But because this is a word problem and X isn't going to be part of the answer, I'm not going to be too fussy about it. So now I need to drop off the X. Ooh, first let's check. Is 18 equal to 14 plus 4? Yeah. And that makes sense. 18 is higher than her average, so it makes sense that her average should be lower. Okay, so how do I write the final answer in box? What am I going to write for that one? Tyler?
14
Very good. Not only do I, write the 14, but I also need to, this particular one comes labeled. So I write 14 points. And you're okay to abbreviate points appropriately. PTS is how we abbreviate that. Okay. All right, one more. Penny bought a dozen bottles of juice on sale for $6.72. What was the price of each bottle? This problem doesn't have 3 sentences, it has 2. So that means there's enough information in the first sentence for me to translate into an equation. What are we solving for in this problem? What's our X? Let's see, Aaron?
X is each bottle.
What about each bottle?
It's price.
Okay, price of each bottle. So they assume we understand a word here. The word doesn't. And what does doesn't mean? 12. Nope, it means 12. Okay? So we have 12 bottles of juice on sale for $6.72. What math do you think is happening in this problem? What operation is occurring? Okay, Kyler? Not division. Okay, that's what we might use to solve, but that's not what it talks about. Yeah, we've got the weird word of, and that's going to tell us to multiply. And we're going to multiply by the price of one bottle, which is our X. And what would be the phrase that tells us equals? Okay, so we're going to, but there was, I guess here was the bottle, but it's really right here. That you're going to get a total of. So our equation would be 12 bottles, each costing X, equals $6.72. And then we would just divide this to come up with the answer.